In this section, we discuss some of the built-in commands that are critical to your scripting success within a Bash environment. Now, there are basically two types of commands as far as Bash understands. There are built-in commands, commands that are built-in or embedded into the shell, that's Bash, or external commands that are actually on the file system. So commands such as ls, remove, those are commands that are actual files, actual programs, typically binaries, sometimes scripts that reside on the file system. Nonetheless, the Bash interpreter ships with a basic set of built-in commands that allows the user of the system to perform functions on the system, such as changing the directory, identifying by echoing to standard out, which is the monitor, the place within the working directory, the ability to set variables, to export variables, the ability to run scripts using the source command, even if the script is not flagged executable, the ability to set aliases. We briefly mentioned aliases as the ability to alias a particular command with desired arguments or desired options. So the Bash interpreter supports aliases. We can set and unset aliases. We can read values in from the standard in or from file or from any location, any descriptor such as the file descriptor, or even from standard in as mentioned before. And the echo command, which is yet another critical command, it allows us to echo to standard out, as well as to echo the contents of a file or text stream received from a file or from standard in to any location that we'd like. These are some of the basics that will help to ensure your scripting success. So let's open a shell window and we'll begin exploring and working with some of the basic built-in commands that are available in the Bash environment. Now, by no means is this a comprehensive list. These are just some of the critical built-in commands that you need to understand. These are the basics. From here, it makes it much easier to understand the more difficult commands. Let's begin with a simple command such as pwd. Now, but when we open the shell, as I've mentioned before, the default is for the Bash environment to display a prompt. Here's a prompt. It indicates the user at the host and a particular directory name, which for the current user we're logged in as root as indicated by the pound or a hash symbol. So you know we're logged in as user root. But how do you in fact know the directory that we're currently in? Now, as you may or may not know, the Linux and Unix file system is organized into an upside-down hierarchy, an upside-down tree, similar to the DNS system used on the internet. So the root is at the top, and beneath root or below root are many subdirectories which contain subdirectories, files, etc. Well, when you use a command such as pwd, it echoes immediately to standard out where you actually are within the file system. So let's try it. We'll do pwd, and as you can see here, we get an explicit absolute path from the root of the file system. So according to pwd, we are located in /root. Now this may seem basic, but once again, this command, pwd, is included in the Bash interpreter. It's a basic command which tells any user of the system where the user is currently located within the Linux file system or Unix file system. This knowledge is transferable to Unix as well. So pwd, print working directory, and it's also known as place within directory, but more commonly print working directory. What is my working directory? Where am I? So we're in /root. Now naturally, along with the pwd command, we should be familiar with the cd command. Most operating systems include the cd command, which allows you to change directories to and from locations within your file system. So currently we're located within /root. Let's say, for example, we'd like to change to a different directory, such as the absolute root, by going up a level. There are a few ways we could do it. We could do cd /. This would take us to the absolute root, no matter how deep we were or are in the directory tree. Or, to go one level up, we could do cd /. Now remember, most things within Linux and Unix in regards to specifying the directory is the opposite of Windows. It's actually / instead of \. So if we'd like, we can specify one of two ways. Either way will work fine. It'll take us one level up in the tree. Now notice when I press enter, the current directory shows up as the absolute directory root because we've gone up a level. Let's do pwd, and it'll indicate that we're actually at the root. So we're at the root of the directory. Now, of course, there are commands that are not built in which can help us to list the contents of files and directories within the working directory, such as ls, and as well as dir. Dir is simply a symbolic link to ls within the Linux environment. ls and dir are not built-in shell commands, so they're not a part of bash. Bash simply finds ls or dir in your path and executes it accordingly. So ls is not a requirement, it simply helps you to use the system. So we've covered two built-ins. We've covered pwd and cd. As simple as they seem, this helps you in your scripting because often you use pwd and cd to have your script move throughout the directory. So those are two built-in commands. You can run help on either of the commands by doing man space pwd or cd, and it'll come up. You'll see options. You can try the same thing for cd, help options, and you'll see for cd it shows up as bash built-in commands. Now there's also a pwd executable, a binary which resides on the system. But pwd is built into the bash shell, and the command that's built into the shell typically takes precedence over the binary which resides on the system. So when we did a man space pwd, it didn't by default show us the help page you see here because it reflected the help of the actual pwd binary. However, for cd there is no binary, and it took us immediately to the bash help. And if you navigate through here, you'll see all of the built-ins, including alias, and a whole bunch of other built-ins that we're not necessarily interested in. And here's cd. It tells you what it does. It changes the directory, etc. So let's look at some other built-in commands. We've looked at pwd, and we've looked at cd. cd allows us to change directories. Before jumping off cd, let's just show you some tricks that are available within the bash environment so that when you tailor your scripts, you can keep these in mind or keep them in consideration to make your scripts more effective. When you execute cd with no arguments, no options, nothing, cd automatically takes you into the current user's home directory. So simply executing a cd will take us back into the root directory. As you can see, this is changed to root, and to verify that, simply do a pwd and it tells you we're in /root. So cd with no options takes you to your home directory. Let's try that again. We'll go back up one level. cd, no options, takes you to your home directory. Let's go up a level, and here's another trick. If you do cd space tilde, the bash shell performs what's called tilde expansion, which is one of 7 expansions that the bash shell performs upon any executing command, and it equates the tilde to the home directory of the currently logged in user. Now the currently logged in user is root, as indicated by the hash mark, the £. So if we do cd space tilde, this takes us directly into our home directory, which is /root. Now you may be wondering, what is the necessity for the tilde equating to the home directory if you could simply execute cd with no options to take you to the same location? Well, oftentimes you want to, or may want to, access directories that are beneath, or files that are within your home directory or beneath your home directory. So by scripting or including in your scripts the tilde, you can say something as such as the following: cd space tilde temp, to a temp directory that may exist beneath your home directory. And as you can see here, it's taken us into root temp. So that's how you'd use it in a script. You'd specify tilde. The bash shell would equate the tilde by default, although it can do other things. But by default, it equates a tilde to the user's home directory, and then you could specify subdirectories beneath it. So tilde expansion is real simple to understand, and it can be used within scripts. But before going off and writing any scripts, you should be able to do as much as possible from the command line, since scripts for the most part execute likewise from the command line. So once you can do it manually from the command line, it makes it much easier to script it. So cd tilde and a subdirectory will take you into a subdirectory beneath the user's home directory. CD with no options takes you to the home directory, and CD with an absolute / takes you back to the absolute root. CD .. / takes you up a level, and you can keep appending .. / it'll take you a few levels up. Let's look at that. We can go into tilde for home, into temp. We're now 2 levels down. If we're to do CD .. / this is a long way of going to the root from 2 levels down. So we're now back to the root by specifying it. So great. So you understand CD, you understand PWD. Another important command is the read command, which allows us to read variables from the command line, which is standard in, which is where we're currently working. This is considered standard in. You can also use read to read commands from a script, from a text file, etc. Let's show you some basics here. Read is a built-in command that allows us to write scripts, write pretty flexible scripts. We're going to read a variable into memory, and we'll give the variable a name such as test. So we'll read test, and when we execute read test by pressing enter, the bash interpreter, the born-again shell, waits for us to give a value to the variable test. So we can give test a value such as testing. And when we press enter, that value has been set, although it doesn't seem like it has been. Now we can use the echo command. The echo command will essentially write to standard out, which is the screen, the contents of anything you specify, such as a variable. So if we were to say echo $, which is the standard way within a bash environment of cross-referencing a variable, echo space $ test, it'll echo testing. So we've read a variable into memory using read, we've called it test, and we've given it a value of testing. So that's really one flexible use of using the read command, because for example within your script you could execute read and have it read a variable and capture a value either from the user, from standard in, or even from a file. Here's another way you can use read. You can have read store multiple variables. So let's say read first name, last name, and it's going to expect 2 variables. If you specify only one, it records the one and matches it to the first variable. Let's call the first name Dean and the last name Davis. So now 2 variables have been set, and if we were to echo one at a time, first name, you'll see it's set to Dean. We'll do the same thing to last name. You'll see it's set to Davis. Now we can echo them both together on the same line, and you'll see that both are still in memory. They don't get removed so fast. So now we have 2 variables, first name and last name, which we use the read command to capture. Here's another neat way to use read. If you do a read with the option N, you can specify the number of characters to expect before exiting. So let's say we want, for example, read number of characters 3. And we're going to read 3 characters into a variable called answer. And now it's waiting for us. So we'll type in 3 characters such as YE. Notice it hasn't escaped, but as soon as I press S, it escapes. We can now echo the variable answer. Now this is all useful within a script because you can capture this information, store it in a variable, and reuse the value somewhere else later on in your script. Excellent. So we have a few variables set. We have first name, last name, and we have answer, and we have test. These variables are all available. These variables can be unset, and they can also be revealed using set. So you can set grep, for example, any of the variables. You see answer is equal to yes, or you can grep last name, you'll see Davis, and it's set. It's all within memory. If we close the shell, then the variables disappear. The variables that we've set here are all tied to this particular shell, unlike what we've done with the profiles, which recur or are reset when we relog into the system. So we can unset the variable. Let's show you, that's another built-in command. We'll unset, let's say, for example, last name. And now if we try to grep last name, it's not set. It's no longer set. If we try to echo it, it's no longer there in the system. It's blank. Let's unset first name, and you'll see the same thing. If we try to echo first name, it no longer exists. So that's how you unset. It's quite simple. So we've shown you pwd, cd, set, unset, and there are other built-in commands that we'll be examining. For example, such as the source command. We can put some of the commands we've done here, as well as more complicated commands, into a file using any editor of choice and source it, or have the bash shell execute the contents of the file. Let's show you an example of doing that. You can use your favorite editor. Typically on all Linux and Unix systems you'll find VI, so it's quite okay to use the VI editor. And we can create a file name using VI, or you can use another editor. For example, I like to use Pico. And the Pico editor, let's go into our home directory first. We'll do Pico, and we'll call this particular script name. You can name it from here, or you can save it after the fact. Either or works. We can give it a name such as test source.sh. Now it's common to name shell scripts with a .sh extension, but keep in mind as you go off scripting in Bash that the Linux operating environment via Bash pays no regards to extensions. So extensions don't matter. They're simply for humans to visually recognize the contents of a given file, but it doesn't mean that the given file contains executable code. It just is proper or good nomenclature to name shell scripts with an extension of .sh. So that's pico test source.sh. We won't make this file executable, and we need to put some things into this particular file. We can place, for example, a command such as echo hello world. This is a very simple script. Now typically when you define a bash script, you should set a header. And that header looks as follows. The location, you specify the location of the bash interpreter, prefixed by the £, then the exclamation sign. This tells the bash shell that the script in question, this file, testsource.sh, is a bash shell script. You'll see in the Perl section we actually change the location here, or the identifier here, from bin bash to bin Perl. So this is a proper way to define a script, albeit this is a very basic script. Nonetheless, the concepts are the same from simple to complex scripts. Excellent. So we now have a script called testsource.sh. Let's Control X to exit. We'll save it. Now if we're to LSL, which shows us the directory listing in long format, testsource.sh, you'll see that the file is not executable. It's read-write, read-read. User group and everyone else. It's not executable. So if we were to try to run testsource.sh, it won't run. And in fact, I'm actually attempting to use tab completion to run this particular shell script. Now, for any command that's executable within the bash environment, you can tab complete it simply by typing the unique portion of the file name and pressing the tab key a couple times if necessary. So if we try to run this by typing out the full name, you'll see it doesn't work because it's not an executable file. However, the purpose of this exercise is to show you yet another built-in bash command called source. If we were to run source, and you can just type a portion of it up to R, which is unique, tab it out. If we were to say source, testsource.sh, look at what happens. Source actually runs the contents of testsource.sh, which simply echoes hello world. So it's quite simple. We can use the cat command, which is another command which is not a built-in, but it helps to essentially echo the contents of text files to standard out. If we're to cat testsource.sh, you'll see that it contains the header, the standard bash shell script header, and a simple command, echo hello world. By running source, it actually echoes the contents, or it executes the code within this particular script file. So we've looked at source, we've looked at set, unset. There's yet another command called export. Typically when you set variables, especially for login environments, when you set a variable, it's a good idea to export the variable so it's available to the user. Depending on the version of the bash shell that you're running, this may or may not happen automatically, so it's good practice to export the variable. So for example, if we're to set any variable name, such as test equals 1 or test var equals 1, it's a good idea to export it. You could also set a variable by simply just typing it out with an equator with no spaces. We could do test var is equivalent to 1000. That sets the variable, but it's not exported. And then type export test var to ensure that the variable is available. And we can now set grep test. You'll see test var has been set to 1000. Excellent. So that variable is now available. It's been exported. It's available throughout our shell environments, no matter how many shells we open. So that's the use of export, yet another built-in command within the shell. So where is the shell once again? If we do a which bash, you'll see it's located in bin. If we lsl bin bash, you'll see that the bash interpreter isn't too big. It's 626K approximately. It's very small, and it contains all the necessary built-ins as well as code to execute in a programmatic fashion and a plethora of features. Remember, when you think about scripting within a Linux environment, it's fully scriptable, it's a programmatic environment, it's a derivative of Unix, which essentially means it's built or was built with programming in mind. So there are all these facilities such as conditions, loops, etc. that we can make use of to automate our environment. But before doing so, you need to understand some of the basics, such as built-in commands, because you'll be using the built-in commands inevitably in your scripts, such as cd, pwd, etc. Another thing I want to show you are some of the variables that are already set on the system that correspond to the built-in commands, such as pwd. Now when you type pwd, for example, it tells you where you are within /root. Pwd essentially pulls this value from a variable which is stored. We can do set grep pwd. Grep is a parser, so we're sending the contents of set to a pipe, and we will, in the pipe section, we cover everything you need to know there. So we're sending the output of set to a pipe into grep into the input stream, and we're looking for a string called pwd. Don't worry if you're not too familiar with pipes yet, because we cover it certainly. Now there are two variables that are important here that the pwd command relies upon. There's the old pwd and there's also pwd. Pwd by default reads this variable. The bash environment, as you navigate throughout the system using the cd command, so as you navigate throughout the file system, the bash interpreter writes and keeps updating the pwd variable. Let's prove it. We'll go to etc and let's grep that same command. It's now going to say that we're in etc. So that if we need to run pwd, pwd doesn't need to actually go to the disk to read the file system. It can simply read the variable which is stored. And there's also an old pwd. Now let's say, for example, you'd like to change directory into your old pwd, and there are other ways of doing this using tilde expansion. We can change cd into old pwd, and it puts us back to root, because old pwd contains the value root. If we grepped again, you'll see that things have been updated. Old pwd now becomes etc, and the new current pwd becomes root. So the pwd command cross-references the pwd as well as old pwd variables, and the bash interpreter is responsible for updating those two variables for the sake of the pwd command. So it's important for you to know, because you'll be using pwd along with cd, set, unset, alias, which we haven't touched on yet, unalias, source, etc. within your command. So for example, you may be wondering, how can you use source? If you've already flagged a particular script file executable, why would you need to use source? Here's a great example. Within your script, you may want to call or instantiate a child process. You may want to incorporate or include the commands that are, or instructions that are in another script or in another file. So you could simply, within your script file, type source and the location to the other file. Let's say root source file. And this would simply do an include. If you're familiar with web programming at all, this is an easy way to do includes. And there are other shortcuts. This is no means, or by no means, the only way to do it, but it is a way to do it, to include the contents or instructions from other files. So those are some of the basic critical built-in shell commands that are incorporated within the bash binary itself. There are tons of commands that are not a part of the binary, which we explore when we script. We'll be calling many of those tools to do different functions for us. Remember, the Linux Unix environment is premised on many, many small binaries that perform discrete functions. And when we shell script, we essentially glue those particular binaries. We glue as many of them as we need to perform the functions that we need. So we'll be looking at some of the other built-ins throughout the bash section, including alias, unalias, and you'll see we'll be making use of all of these built-ins as well as the commands that are not built in throughout the bash section.